Okay, Bismillah. Okay, folks, welcome back. We were looking at our Excel exam questions on histograms, part 2. Question number 6. 100 hikers went for a walk. The times taken by the hikers to complete the walk are summarized in the table. So you have time, we have a number of hikers, which tells us how many hikers we had, and we'll use the information given in the table to calculate an estimate for the mean time taken to one decimal place. Now, that's not what we're doing today. But just to give you an idea how we would do that, we would work out the mid value of this range of data here, multiply it by the frequency, which is this column, and then add up all the totals and divide it by 100. If you reckon that, okay? But we're not doing that right now. Part B. Given that the frequency density for 40 to 60 time interval is 0.75, complete the histogram. So first of all, what we're going to do, we're going to complete this table. Okay, right, we need to draw some lines in there. So can you do this in your work now, please? Abdullah, can copy that?
I've done this question, Mohammed.
Yeah, well, check it then.
Right.
Check that it's been done properly as you do it.
Yeah.
Okay, right. Now what are we going to call this column? This is going to be called what? Frequency density. Okay, here we go. Now, what we need to work out first of all, girls, is what? From here. Once we know what the time is, we need to work out the class width, which is how wide the class of data is. So 0 to 25, Abdullah, give me the first one. Class width is? 25. Yeah? Class of the next one, Harun, is? 10. And the next one's going to be? 5. And the next one's going to be? 20, the difference between them, yeah?
30.
And the next one's going to be 30, and the last one's going to be? 10, lovely. What did we say before? We said to work out the frequency density, so the frequency density is equal to the frequency divided by the class width. That's the formula for working out the frequency density. So what we're going to do now, we are going to do 15, which is your frequency here. This is the frequency column. So 15 divided by 25. They told us that the 40 to 61, which is here, so 15 divided by 20, they gave us an answer of, was it? No. So that's 0.75 is the answer to that. Can you double check that for me? Any calculators, please? So we're going to do this quickly today. So 11 divided by 10, 27 divided by 5. I need answers for these, please, folks, quickly. And I will check them against whatever here. Can you calculate them in the back row, please? Grab them.
Okay.
Okay, wow, that's not too. Okay, hang on 1 second. Whoa. What's happened there? Let's pause that for a moment. Okay, 15 divided by 30. And 12 divided by 10. So we need to write down the answers for all these in this column over here. So 15 divided by 25. Just give me 1 moment, folks, while I grab something. Okay, here we go. So the first answer, 15 divided by 25, will give us what?
0.6.
0.6. And the next one's going to be 1.1. And the next one's going to be
5.4.
5.4. And the next one over here is going to be 0.75. That one's done, yeah. 0.5 is the next one. And the last one is?
1.2.
1.2. 1.2. Okay, now what we need to do now we've got the frequency density, that's already been calibrated. We can literally now just draw our bars on there. So let's draw our bars. Have a rectangle. Okay, what color we can go for? Okay, let's go for red. Okay, folks, come inside quickly. Settle down. So the first one is 0.6, which is going to be the first one across. Now we might need to put on some numbers on the bottom over here. First of all, so 10, 20, 30, 40. Calibrating the bottom there. So 60 is that one. Okay, 70 is the next one. Then it's 80. And then 90. Okay, so let's start doing a rectangle. The heights have already been given to us. Now we need to go up by 0.6 and across to 25. So where's 0.6 is here, so bear with me, folks. To 25, yeah? 25 to the best of my ability is going to be there. That's the first one done. The next one is from 25 to 35 at a height of 1.1. So, height of 1.1. Where's 1.1? 1.1 is here. Go back over here. Okay, folks, mine's slightly out, please, bear with me if just I'm trying to get to grip with this. I think I've gone across too much. Have I gone across too much, folks? Yes, I have. I've gone to 35. So let's remove this half off here. Okay, let's remove this bit there. That's lovely. I should have come down a bit. Okay, let's go for a line.
You need to put it 5 more across.
Oh, sorry, 25 to 35. Yes, okay, yes. We need to go across by another 2.5 squares. Thank you. Right, sorry about that. Right, let's just do that one again. It's so... Okay. The next one we're going to do... Okay, we're going to go from 35 to 40, and the height of that one will be 5.4. So from here... So 5.4 is going to be... Whoa, that is just too much, man. Oh, yeah, 60 to 90 is 0.5. Okay, 0.5 is going to be to the first one, yeah? Okay, that's done. And the last one, 90 to 100 will give us what?
1.2.
Alhamdulillah. And that's the best I could do. I'm sorry for any little discrepancies. But that's the calculation, that's that one done. Alhamdulillah. That's good. Okay, folks, now next question. We need the box again. The incomplete histogram and table give some information about the distance some cyclists travel each day. Frequency density has not been calibrated. We need to calibrate it. Distance is here. Frequency here. We need another column. Or we can even just write the calculation on the side if we don't do another column. So let's have a look what we're going to do with this question here. Now, we always first of all work out the what? We work out the class width. Class width is the upper bound of the class minus the lower bound. So 5 minus nothing is 5. 10 minus 5 is 5. 20 minus 10 is 10. And 40 minus 20 is 20. 60 minus 40 is 20. Okay, lovely. Now, to work out the frequency density, what we need to do, we need to get the frequency and divide it by the class width. So I'm going to do this one without the table this time. 15 divided by 5.
3.
So that gives us frequency density of 3. 20 divided by 5.
4.
Is 4. Now, from this here, we can calibrate the scale. So what do we know here? We know that the second bar has a height of 4. So that's 4, that's 3. Okay, it's quite difficult actually to read it here properly, but I'm going to try my best. That's 1, and that's 2. Okay, where's 2? 1.
2 would be about halfway.
Okay, that's right. Actually, 3 is right here. 2 is, I'm literally having difficulty with the lines here. So that's 2, and 3 is not that one. Okay, let's flip the alphabet. Get back to 3. 3 is here. Because don't forget you're going up to 3, isn't it? That is 3 there. Okay, so you got 1, 2, 3, 4. So we calibrated our scale. The lines 1, 2, 3, 4. Okay, now what we need to do now, we need to work out the frequency for the third bar. To work out the frequency for the third bar, what is the frequency density first of all? The frequency density for the third bar is, okay, what is it? Is it 2 point? What is it, folks? 2.5, lovely. So the frequency density is 2.5. If you want to work out the frequency, what do we do with the class width and the frequency density? What do we do with them? We multiply them. So you 10 times by 2.5, that'll give you a frequency of 25, because the frequency actually is the area. So we work out the length times by the width in that case. Next one, the next bar, the fourth bar. What is the height of the fourth bar? Abdullah. Okay, you give me some good answers there. Okay, well, Abdullah, what did you get for your height of the fourth bar, the frequency density?
I've got
0.8. So we got 20 times by 0.8. That gives us an answer of
15.
20 times by 0.8. 16. Thank you. And that's done. And we need to draw the last bar. Now, we got 15 divided by 20.
0.75.
Lovely. 15 divided by 20 is 0.75. Now, 0.75, so we're going to go up by 7.5 squares, which is going to be slightly less than that. Okay, let's go for that.
So you missed the 5 out.
Oh, thank you. Okay, lovely. Okay, right. Rectangle. So we're going to go from 40 all the way to 60, and we're going to go down by 1 little square less. Half square less, actually. Actually, that's quite difficult to do, half square from the bottom. Okay, let's, no, that's wrong button. Rubber. Okay, let's do it again from the bottom. Rectangle. Okay, I need to try to do it as the best of my ability. The technology we have available. Lovely. Okay, that's supposed to be halfway, it's supposed to be all the way to the end. So just my question has dropped a bit short. Okay, right. That should be halfway between one square and the next one up. That one's done. End of that question. There's a Terry asked the students in the class how many hours they played at computers last week. The incomplete histogram was drawn using the results. Frequency density not calibrated. Hours watched has been calibrated. 8 students played for 10 and 15 hours. 6 students played for 0 to 10 hours. Okay, so they're giving you some information there. They haven't given you a table at all. So let's try to make sense of that information. Okay, so it says that 8 students played from 10 to 15. So that is called that 8 students is called the what? Frequency.
Yeah, that's it.
Okay. And 10 to 15, that is your, what is the class width for that one? 10 to 15, the class width is 5. And if you want to work out the frequency density, what do we do with those two values? Frequency density equals frequency divided by class width. So it's going to be 8 divided by
The answer is 1.6.
5. So the answer will be here, what will it be?
1.6.
Okay. 1.6 is correct.
Yeah.
Oops, I'm about to make a mess of it here. Okay, this pen is just so ridiculous. Frequency density is 1.6. So from that information there, we know the frequency is 8. They tell us there's 8. We know the class width, we divide them, get the frequency density. So the first one, so we know that this 8 students from, so this height is?
4.
So this is 1.6.
Whatever.
That's what we just worked out. That's 1.6. And this one here is going to be, so that's 1.6, what's the next one down going to be? 1.6,
5.2.
1.2. This one here, the big one. Okay, and the next one, big one down, is going to be what? 0.8. 0.8, well done. So that's big one down. And the next big one down is going to be what?
0.4.
0.4. So each big box is worth 0.4, each 10 squares. And that's going to be 0. So we've just calibrated the scale. Now, it says here, use the information to complete the table. Okay, so it says here, 6 students played from 0 to 10. So we've got to go from 0 to 10 and 6. So 0 to 10, what's the class width from 0 to 10? Class width is 10. And how many students do we have between those? 6. 10 divided by 6 is equal to 0.6. So now we need to draw a rectangle. That is 0.6. From here. So we need to go up to 0.6, which is halfway. Okay, are you happy that's 0.6, folks, there?
Yeah.
Wow. That should be 0.6 on the scale, 0.4, 0.6, 0.8. I'm slightly out, folks. Make sure yours is in the right place. Just when I let go of the pen, it moves around a bit. Should be 5 squares above there. From what I can see, it's 1, 2. Okay, my 5th square has been a little bit chopped, okay? Yours should be like less than a millimeter less down. So it should be down. So you should see that full square. So apologies for that in advance. Okay. It says no students watch television for more than 30 hours. Work out how many students Terry asked. Okay, to work out how many students Terry asked, what do we need to do? We need to work out the what? That is called the frequency. How do we work out the frequency for the whole data? What do we do? To work out frequency, generally what do we do? To work out the frequency, we have to work out the area. So we need to work out the area of each block and then add it up. Okay. So, well, hang on a second. It says, we already know that in this particular block here, how many people were there? 6. And how many were in here? 8. So we got to work out the area for these 2 blocks and then add them up. Okay. So what's the length here? 20 to 30. The length on the bottom is 10. And what is the height here? For the last block, the height is, anybody give me the height? Height here is 0.5. Okay, 15 to 20 here, the length on the bottom is 5. What is the height for this next block here? The next block is, what's the height? Is exactly 1.2. So we need to work that out. So what's 5 times by 1.2? 5 times by 1.2 will give you a frequency of 6. Okay, what's 10 times by 0.5? 5. So we now need to add up these values. I need to add between 6, add 8, which was already given to us. 6 we just worked out, and 5 we just worked out. So, tell me what happens when you add up all those together. What do we get?
You get 6, 25.
So it goes there, how many? It goes there,
5.
25, is that right?
Yeah.
Beautiful, bang on right answer. Lovely. Okay. Question number 9. Are we happy so far? Abdullah, yeah? Happy to have you going backwards and forwards while we're working out here? Saf? You good? Harun?
Yes,
Is it making more sense? Okay, good. Now, can you see these lines are a little bit light on the graph? Can you see the line there, that block there? Can you see them just about?
Yeah.
Can you see them there? Just about, yeah? We're working on this table now. So, first of all, here we go. Some context for number 9 is trains from London to Birmingham. What do we need to work out here? Class width. So the class width is 5. Class width is 5. Class width is 10 and 10 and
20.
And 20 for the last one. Are we happy with those? Okay, we're going to do frequency density. We're going to do without doing a table part. We're just going to work it out. Frequency density equals the frequency divided by the class width. So 16 divided by 5. 10 divided by 5. 6 divided by 20 and so on. Okay, let's write that 5 properly. We need to calibrate the scale. We've got the first bar there. What's 16 divided by 5, folks?
3.4.
Beautiful. So the frequency density is 3.2. And if you look at the scale here, here's our 3. Okay, so that makes that part there 3.2. So here's our 1, here's our 2, and here's our, oh, how come 3 is over there? Okay, that's 1. Okay, what's happened to the scale? 1, unless we can't do wrong in the squares. 1.4. Okay, so the first one is 3.2. Okay. That's actually 1.6. Okay, folks, a little bit of an error there. Each half of the square is worth 0.4. So that's our calibration scale. So that's that one up there. That is 3.2. Okay, so the bottom we're going to have 0.4, 0.8. Okay. It's difficult on the graph here on the screen. That's 0.4, 0.8. No 0.4, 0.8, we got 1.2, 1.6. One 2.4.
So what are you doing?
Trying to the scale.
Making it accurate.
Wow, trying to put some scale on there. It'll be easier on yours. Okay, now, so we got the first bar drawn for us. The second bar is 10 divided by 5. We'll have a height of 2. So we start from the bottom and we go up to 2. Okay, so we got one more bar to do, the last one. 6 divided by 20. What's 6 divided by 20?
2. I mean, 0.3.
No point. Is it 0.3 recurring or something?
No.
It's just 0.3.
Yeah.
Okay, 0.3. We'll do the next one, 0.3. The last one. So from 30 to 50 is 0.3. So 0.3 according to this should be 1, 2, 3, about 4 squares up approximately. And that's the end of the drawing part. Now we've got to work out the frequency for these two over here. Now how do we work out the frequency for these two? What is the height for this one? The height for that one is 1.2.
Yeah.
And the height for this next one over here, this height is going to be what? 0.6.
6.
0.6. Lovely. You guys have got some nice values. 0.6. Now we've got to work out the frequency. What do we do? These two values? Times them. So that gives us a frequency of 12 and a frequency of 6. Done. Lovely.